This webinar is called AutoVu Best Practices and Resolving Top Issues. A quick word about myself here. I've been working with Genetec for about 5 years, a little bit more. And before I joined the technical training team, I was working as a support engineer for AutoVu. I do technical training and content development. I speak English and French. And my specialty within Genetec is the AutoVu product line license plate recognition. Of course, if you've met me before in a training class or in another webinar, you might know that I have a teeny French accent, but of course I'll do my best to make sure you guys understand what this webinar is about. This is a webinar, and as all of our webinars, it is being recorded and it will be posted on the GTAP. The GTAP, Genetec Technical Assistance Portal, is your key resources to access many webinars, all the documentation, and a lot of other things available to help you when using Genetec products. About this webinar, a few things. This webinar is co-written by our AutoVu product specialist, the AutoVu technical support team, which helped us a lot finding what help you guys need, the field engineering team, and of course by you. By all the feedback you give us, by any support call you make, we value this feedback and we learn from it. So thank you. We invite you to continue providing feedback to us. It makes our product always better. The main focus of this webinar is to provide you with Genetec best practices when it comes to deploying an AutoVu mobile system. We would like to talk about the most challenging parts of a mobile deployment. Yes, this webinar is about mobile deployment. And of course, we will focus a lot of time and energy on talking about the Patroller application and our Sharp product line. This webinar is intended for our Genetec premium partners, which I salute, any AutoVu mobile installer, and any Genetec partners willing to extend their knowledge on a mobile deployment. This is a no prerequisite webinar. However, general knowledge on AutoVu product line would be advised. Knowledge on AutoVu mobile deployment is recommended. And if you haven't attended this class, we may only strongly recommend it to you, the SC-AMC-001 certification. If you did not attend this class, this is okay, stay with us. This would just be a plus. A quick word about the SC-AMC class. This is never too late to sign up. This class is offered by the Genetec Training Department. It's a 3-day class, and this class will cover everything you need to start doing mobile deployment. Here's the different objectives of this class, which is mostly about starting from scratch and installing all the different packages we offer for mobile deployment, starting with law enforcement, city parking, pay-by-plate, university parking, and mobile license plate inventory. Real quick here, I just wanted to talk for a minute about the outline of this class here. We talked about all the LPA hardware Genetec offers, security center architecture, how to configure the main role, and the different type of Patroller packages, starting from installing the Patroller, using it for law enforcement, pay-by-plate university, inventory mode, some system design, including camera positioning, for instance, and some guidelines about hardware installation. Again, we offer this class everywhere in the world, and please inquiry to training@genetec.com if you wish to sign up for this class. Now let's talk about this webinar. It's a very special webinar. For first, it's going to be a 3-hour webinar, which is slightly longer than usual, but we have a lot of very exciting things to show you today, and this is going to be a well-invested time. Now, at the end of this webinar, there's going to be a quiz. Now, this quiz is purely optional. You don't have to take it. This is going to be a 15 questions quiz. Most of the question will be multiple choices. It's going to be time limited to 60 minutes. You will have the answer to all of the questions and your score directly after taking the quiz. And scores and any other information will not be shared or saved. So now you're wondering, why would you take this quiz? I would be wondering the same. Well, if you are already SC AMC 001 certified and take this quiz, you will have an extension of 18 months of your certification. And even if you're not certified with SC AMC 001, there's going to be a gift for the top 3 scores for the people attending this test. Now, I won't tell you right now what is this gift, but if you stay with me for the duration of this webinar, you will know soon enough, and it's very, very exciting. Now, let's talk about the webinar outline. When we looked at the best practices and the top issue you guys met when you do a deployment on site, we decided to break down all of those top issues into 3 sections. The first section, called planning, will be mostly a refresher on general knowledge about the AutoVu product line and general consideration about AutoVu architecture. The second section, called deploying, we'll talk about key deploying guidelines, and yes, we will spend a lot of time talking about camera positioning. Eventually, the last section here in this webinar will be supporting, and I was able to poke our support team, and they came up with very, very interesting insights and key mistake you should avoid when you deploy or when you need to support this product. It's going to be very interesting. Now, again, I said this is going to be a 3-hour webinar, and what we will probably do is we will stop right in the middle, maybe for 5 to 10 minutes, and I will be able to take your questions. Because we have many people attending this webinar today, what we will do is I invite you to type your question in the question box, and once we hit our first break, I will look at those questions and I will try to cover as many as I can. Eventually we'll resume the webinar and we will finish for those who are willing by taking the quiz. If we look into more details into those 3 sections, let's see here what we have for you guys today. In regards to planning, we will talk about our AutoVu product line, just a refresher. We will talk about the Sharp internal components, how those devices works. We will talk about camera positioning, and we will cover a bunch of general use cases. Eventually, sometime there might be a need for a new LPR context. Let's talk about how do we do to help Genetec build a new context or update a context. We're coming up with new documentation. One of this new documentation is called the deployment questionnaire. I'd like to talk about this document. This document is here to help you when doing a deployment. Moving on to the second part of this webinar, deploying, we will talk about another new piece of documentation, the AutoVu field report. Very interesting. It seems like navigation and navbox give you a lot of work, so let's talk about it and let's try to address the main concern about this part of the product. Eventually, when it comes to a mobile installation, wiring is key to a successful installation. So how about we come up and offer you some interesting wiring guidelines. We will talk about the Sharp processing unit installation. Again, here we're coming up with new documentation, which I will be able to show you. And eventually we are I am very exciting to introduce you to our benchmarking tool. So we will discuss benchmarking procedure and how to assess how your system is doing. It's going to be our section 10 here in this webinar. Eventually, after completing a deployment, I would like to talk about supporting an existing installation. We're going to talk about new and old troubleshooting tools available in the Sharp portal and in the patch roller to make your life easier. Eventually, as a bonus, at the very end of this training, we're going to talk about different hints and tricks coming from the support team. Alright, let's not wait any longer and let's talk about planning. Because it's the beginning of the afternoon and maybe you guys had a nice lunch, let's start easy here. And let me remind you about the different products Genetec offers when it comes to AutoVu. In this table here we see the different LPR product we have. So I'm going to start here with the Sharp 2. So we still offer Sharp 1.5. We have Sharp 2, which comes in two flavors, VGA and XGA. Again, as a gentle refresher, when we say VGA or XGA, we refer to the LPR camera, the camera that will acquire the picture in order to find license plate. VGA refers to a resolution of 640 by 480, while XGA refers to a resolution of 1024 by 768. Of course, the increase of pixel will have consequences on reading, but this, of course, we'll talk about it a little later. Here you see more interesting specification about the Sharp 2 product line. We see the type of context camera we use, the LPR, the processing specification. Here you see those devices run Intel Atom N450 and the RAM available. I'd like to talk here about the Sharpx, which comes in two parts. Again, this is a reminder. We have the processing unit, which you see here in black, and attached to the processing unit we may connect up to 4 Sharpx camera, which are the two devices you see here in white on the right and on the left of the Sharpx processing unit. Sharpx comes in different flavor depending on your needs and maybe your budget. And I'd like to remind you here about the different version we have. We offer Sharpx 1, Sharpx 2, Sharpx 2M and X4M. Now, this is actually a lot simpler than it looks. If you look here, let me see if this works, there you go. Here, if we look at the Sharpx 1 and the Sharpx 2M, internally, those two devices are very alike. They both have a single processing unit. You see here. Now, the key difference between a Sharpx 1 and a Sharpx 2M is the number of camera you may connect to it. If you go for a Sharpx 1, you have a single processing unit and you may connect up to 1 camera. A Sharpx 2, which has the same processing power, will be able to connect 2 camera to it. Of course, if you want to maintain the highest FPS, frame per sec, if you decide to connect 2 Sharpx camera to a Sharpx 2M, to maintain 30 frames per sec, you will have to go for 2 VGA. If you decide to connect 2 XGA camera to a Sharpx 2M, then your frame rate will be divided by 2. This is still very interesting option, especially at low speed. Moving on to the other product, I'd like now to talk about Sharpx 2, which is a bit similar to X4M. They both have 2 processing units. Now here I just want to clarify something. When we say 2 processing units, we don't mean 2 CPU or a dual core CPU. We literally mean 2 complete processing units. What it means is the performance of one processing unit will have absolutely no impact on the performance of the other processing unit, making sure you can achieve the highest frame per sec on both units with no dependence. X2 and X4M have 2 processing units. The difference here is the X2 has connectic for only 2 camera, while the X4M has connectic for 4 camera. Again, same thing applies as the X1 and the X2M. If you decide to use 4 camera on an X4M, then you should go VGA to get your 30 frames per sec. If you decide to plug 2 XGA per processing unit on an X4M, then expect your frame rate to decrease. Eventually, for those doing deployment in city parking with wheel imaging, the X4M will not be a suitable product because it has no connecting for the analog tire camera. So in this case, you will have to go for a Sharp X2, a Sharp X1 if you want to have only a one-side system, or two Sharp X1. Sharp X4M will not be suitable as the connecting is non-existing for the tire cam. I hope this makes sense to you, and I'm going to continue. The Sharpx architecture is very flexible. Now, we discussed all of the options you have based on the type of product you select. But for instance, if you decide to go for a Sharp X4M, giving you 2 processing units and 4 connected, nothing prevents you from going with 2 VGA connected to 1 processing unit and a single XGA connected to the other processing unit. This way you will still achieve the best frame rate and have a very mixed system. Later on in this training, we will be discussing different cases, and we will see that there is actually a very interesting practical case for an installation like this one, 2 VGA and 1 XGA. Let's talk here now about Sharp internal components. One thing we hear a lot from our people from support and from our field team is that people often forget that unlike a Sharp 2, which just has 1 IP address, a Sharpx might have up to 9 IP addresses. Now this might not make sense to a lot of people, it's a single device after all, but if we look closely, there's actually a very simple explanation about it. Let's talk about it here. This is a different view of a Sharp with 2 processing units, a Sharpx with 2 processing units. Now, here on this part, we have the SBC1. SBC stands for single board computer, or if you prefer, processing unit. Now, the SBC1 will need its own IP address. I'm going to say 10.1 for instance. If you have a Sharp X2 or a Sharp X4M, you will have 2 SBC. Now SBC2 will also need an IP address, so it's probably going to be 10.2. When it comes to video processing, we have another component that we call GVP. GVP stands for the Genetec Video Processor, and we need 1 GVP per processing unit. So the SBC1 will communicate with GVP1, while the SBC2 will communicate with its own GVP. To ensure communication, GVP have their own IP address as well. And in this case, GVP1 will get 10.3, while GVP2 will get 10.4. So right there, we're using 4 IP addresses. Now, of course, what would be a Sharpx with no camera connected to it? And as you know, if we go for a Sharp X4M, we might be able to connect up to 4 cameras. Now, in this case, we will connect 2 cameras to the first processing unit and video processor. Those 2 cameras will require IP address. And 2 more cameras, camera number 3 and camera number 4, to the other processing unit. Which makes it for 6 IP address if we allocate 1 IP address per camera. Now this is a lot of IP address, and we want to make this product easy to use and convenient. So we don't expect you, if you wish to change the IP address of a Sharpx, to go on every part of your device and change the address. This would be very time consuming, and this is obviously not the case. So we have the MPU. The MPU is the mobile processing unit, and the MPU will, among other things, manage IP addressing in your Sharpx. So what you do is the following. Should you change the IP address of your camera to meet your network scheme? Let's say here, we're going to go for maybe 10.5. 192.168.10.5. What will happen is the MPU will pick up the new static IP address here, set for the first processing unit, and will automatically reallocate new IP address to the other devices following this very specific order, which means that the MPU will automatically give 10.6 to SBC2, 10.7 to GVP1, 10.8 to GVP2, and so on. So as far as you're concerned, the only thing you need to take care of is change the IP address of your SBC1, and the Sharpx will take care of everything else. Now this is fairly straightforward. Now the problem we see is you might allocate 10.5 and maybe use your wireless router or any other device you run in your mobile to use maybe 10.7 and 10.8. And this is where we have a problem, because you will end up having an IP conflict, and this could lead to some complication during the install. So remember to allocate the IP address of SBC1, and of course remember that the next 7 IP addresses will be used by the other components of the camera. Also, the other thing I wanted to say here about this slide is you only need to take care of your SBC1, so don't try to change the IP address on your SBC2. The IP address of your SBC2 will directly result from the IP address you have set for your SBC1. Okay? Moving on from hardware to software, we often have a lot of questions about how does it work inside the box. And we wanted to take this opportunity, this webinar, to discuss further what are the software internal components of a Sharp equipment. Being a Sharp 2, being a Sharp EX, or being a Sharpx, the components are the same. You see them here. We have the Genetec Sharp HAL, which stands for hardware abstraction layer. We have the Genetec Sharp Logger, the plate reader, the Genetec Sharp Portal, and the updater service. Now, how does those components work? How do they interact? And what do they do? Let's take a minute here and talk about it. The Sharp HAL is pretty much in charge of taking care of your hardware. By hardware, we mean the illumination board, the LPR camera, and the exposure control. So the HAL will be the bridge, or the interface, if you will, between the other services and the actual hardware of your camera. The HAL will talk to the Sharp plate reader, which is really the core of our hardware. The plate reader is the role that will process the incoming images and find license plate and extract metadata. So this is where the magic happens. This is exactly where we will be able to find plates and populate the information. To be able to interface with the Sharp camera, you probably know this tool by now, we use a web page. This is what we call the Sharp Portal. The Sharp Portal will let you, using a specific URL, connect to your Sharp device and do any configuration. So the Sharp Portal is really the interface between us, the user, and the hardware itself. So Sharp Portal will pass on the configuration to the Sharp plate reader. Because all of those roles are very specialized, there's something very interesting about it. You might be able to turn off the Sharp Portal and your camera would remain functional, except you would not have access to the web page. This is not it. We have an additional service called the Sharp Logger. Now the Sharp Logger, properly named, will pretty much gather information about how your hardware is behaving, about how your plate reader service is acting, and log all of those information into a local database. The Sharp Logger is mostly used by our folks in training, in support, to troubleshoot and make sure the camera is behaving properly. Of course, it is possible to query the Sharp Logger using the Sharp Portal and obtain any sorts of information from there in the diagnostic page of the Sharp Portal. Here we have the type of communication. In yellow, this is the hardware command and control, while in blue, we have service communication. That's not it. We have fifth services called the Sharp Updater service. Now you might have used this service before. This is here to make your life easier. The Sharp Updater service will talk to your LPR manager, your AutoVu server if you will, and if an update is available on the server, it will be sent to the Updater service, which will take care of doing a local update. It will update all of the services required, which would be the plate reader or the Sharp portal. The Updater service is always listening for any update and will do everything for you. Extremely convenient, especially when you have a large number of Sharp devices. Now, this is a very important part here of this webinar. I'd like to talk about camera positioning and general use cases. Now, I want to give you some additional information. Depending on the type of hardware you guys have, the exact field of view will be slightly different. Here, for instance, if you get a Sharpx XGA in tall, you will get something like this. Now, if you get the wide version, mostly used for mobile, you will see that the ratio, the format is not exactly the same. Now, if we talk about Sharp 2 XGA, you'll see that it's slightly smaller. And eventually, of course, if you get a Sharp 2 VGA, the large decrease of pixel will make the field of view a lot smaller. Now, I wanted to stack those here to give you a better picture of the difference between the version. So now you know what's the difference between tall and wide. Of course, if you've attending any of the AMC training, you should know by now the lens matter. We offer different lenses which will give you very different results. For instance, let me take an example here. If you attempt to read, let's say, a license plate pretty much 16 feet away from your device, depending on the lens you pick, the result will be very, very different. Here, for instance, on the top, in here, we have a Sharp 2 or a Sharpx VGA with a lens of 12 mm. Now we see that 16 feet is a good distance and give us a pretty large field of view. If we change this equipment for a Sharp 2 VGA with a 16 mm lens, we see that the field of view is a lot longer, I would say, but at 16 feet, your field of view will be larger. Eventually, if you look here at the bottom, for a 25 mm lens, it is going to be the shorter field of view at 16 feet because it's at the very, very beginning of the reading zone. So in this case, a Sharp 25 mm would probably not be the smartest choice. The choice would be between the 12 and 16 mm depending. If you expect all of your camera to be, your license plate to be at 16 feet, maybe 12 mm is a good choice. If you expect your camera to be at 16 plus minus 2 to 5 feet, maybe 16 mm would be a smarter choice. Now, if you looked at the AutoVu handbook, we have some information about the different field of view available. Our product specialist here in AutoVu has been doing a lot of work giving us more information about this. Now, the information I'm about to show you and much more will actually be published in a document and available to all of our integrators. Here I wanted to show you a sample of the work he did, which will give us a much better picture on the practical reading zone for any camera. Let's talk about here a 16 mm camera, and let's talk about the difference here between VGA and XGA. Here, for instance, if we look at the VGA camera, we see a maximum reading distance of 23.34 feet. This is all in feet, by the way. And we see that the beginning of your reading zone starts at 9.73 feet. Now you see this chart, those charts are color-coded, which is very important for us. Of course, the best part here is going to be green. Now yellow is readable, but not optimum, and red means your license plate won't be picked up. So, according to this document, your reading zone would pretty much end here and start at pretty much 10 feet, giving you something like nearly 14 feet of reading zone. And this is in VGA. Now if we look at the other one here, which has slightly been rescaled, for XGA, we see that the increase of pixel has a lot of consequences. Now, of course, this is something we would all expect. The reading distance, the maximum reading distance has increased from 24 feet to nearly 30 feet. This is something we would expect. But if you look at the minimum reading distance, which I'm going to highlight here, it's not quite the same. While we start at 10 feet for a VGA camera, the XGA camera will only start at 12.5 feet. So this is also something to take into account, giving you a much wider and larger reading distance from here to here. Again, you don't need to take notes. This information will be published soon, and we will make it available to everyone. I'd like to do the same exercise here with a 50mm lens. Now again, this has been slightly rescaled to fit in the PowerPoint, so keep this in mind, but the numbers are very accurate. And here we pretty much see the same thing. I'm going to zoom in here on the VGA. And we see that VGA starts at nearly 30 feet for a maximum distance of 73 feet. While if we go down here to the XGA, it only starts at 39 feet, which is nearly 10 more feet, and will end at 93 feet. This is 20 more feet from the VGA version. So in a 50mm scenario, we see that XGA gives us a large advantage in distance. So of course something to take into account when making the decision between VGA and XGA. Now we're going to stay with VGA, and I wanted to show you this one as well, which is going to give us information on the different lens used, again all in VGA. Now we see that the difference is quite significant. For a 12mm lens, for instance, the maximum is going to be nearly 18 feet. I'm going to zoom in here. Hopefully you can read the number. So we're looking at 18 feet. 16 will give us pretty much 5 to 6 more feet. 25 will go up to 37 feet. 35 will go to nearly 51 feet. And of course, the 50mm lens will go to 73 feet, which is what we've seen on the previous slide. If we do the same exercise here, this time with an XGA lens, and look at all the different lens we offer, the distance will be obviously slightly longer. Let me zoom in here one more time. Here we went from 18 feet, if I recall, to nearly 22.5 feet. 16mm will give us up to 30 feet as maximum distance, and an 18 feet reading distance. By the way, when I say reading distance, I refer to the distance between your maximum reading distance and your minimum reading distance. Here in 25mm, this one here, we get 28 feet, which is 10 more feet than the 16mm lens. Sorry about that. And 35 here give us quite a long range, and of course the longest range will always be obtained by a 15mm lens, with a total reading zone of nearly 55 feet. Now more than ever, we see it's color-coded and you see the absolute optimum reading zone. It's pretty much here. Now, your system will read, but if you want to stay in your optimum reading zone, this is the one I've highlighted in red. Now, let's talk about a few facts here. Reading accuracy is directly dependent of the camera positioning. We do talk a lot about this in training, but again, I have to insist, it's all about camera positioning. The resulting field of view may vary depending on the hardware. Here I'm obviously talking about the different resolution available. Lens and LPR camera resolution will also have an impact on the field of view. As part of the document we're about to produce, including the field of view I've previously showed to you, we're going to produce a bunch of tables, such as this one, which is for the Sharp 2 XG et al., which has a resolution of 1024 by 768. And here, depending on the lens being used, we're going to give you the maximum width, the maximum height for your field of view, the minimum reading distance, and the maximum reading distance. You will also have the depth of the field, and all of this is in feet. There's a tool we talk a lot, again in training, and I hope you know this tool and you've used this tool. This tool is the Sharp Field of View Calculator, and this tool is available to any of you, and we again strongly advise you to try to use it to simulate before you actually deploy. This tool will help you find the best position and try different lenses without actually having the hardware. Now there's something very interesting about this tool. When we use it, we set it in a specific way. Here, let me zoom in, hopefully it's gonna work. Here, of course, if you're not very familiar with this tool, this yellow dot here refers to your camera. This is a top view of your scene, your site. And here we see two dotted lines. One dotted lines here at 7.25 feet, another one here which was placed at 7.5 feet. Now those two lines, they refer to the two following argument here. Maybe it's difficult for you guys to read, so I'm going to tell you. Here it says lane horizontal distance closest. And the second one here says lane horizontal distance furthest. Now, before we argue about the name being used here, they actually refer as we would expect, to the center of the closest lane from the camera. So here I'm going to attempt to illustrate. If this is the edge of your first lane, this would be the center of the lane. Now we do care about the center of the lane because this is where we expect the license plate to be, should the driver not be drunk. Of course, here, this would be the separation between the two lanes, and this would be the second lane. And again, this would be the center of your second lane. Let me say this here one more time. What you see here, this dotted line, is what we call lane horizontal distance closest. Now, this is one way of using the simulator, but there's actually another way, a very different way, which is much more interesting, especially if you wish to simulate a single lane scenario. Now what you could do is the following. Instead of using those two lines as the center of your closest lane and the center of your furthest lane, you could use those two lines to set up the edge of a single lane. And in this case, what you see here as two dotted lines would not be the center of the lane anymore. It would be the edge of your single lane. So if it lets me, there you go, perfect. Now those two blue lines you see here would actually become the two edges, and your vehicle would actually cross between the two lanes. So this would become the right edge of your lane, while the other settings, the furthest setting, would become the left edge of the lane. Again, if this is not clear enough, here your vehicle would actually be in between, and it would transit through the lane this way. Now that's a very, very interesting approach, because it's going to give you very, very interesting data when you simulate about your different type of license plate. Here, let me stay on this slide here for 1 more minute. What you see here in green is the projected field of view of your camera on the ground. Well, almost on the ground. Which means here your license plate will actually transit through the center. Again, if we expect the person to drive straight. Now, if the person is not driving very straight, we know that always the license plate will be within those two lines. Now, you're probably wondering, if you simulate this way for a single lane application, this data will not seem so relevant anymore. Well, actually, it's very interesting, because this data giving us the transit distance for the two edges of your lane will actually give you the two worst case scenario. The case where the license plate is actually on the edge of the lane you're trying to simulate. And if you simulate the two worst case scenario, and if they match, then you can be pretty much sure that any license plate within those two lines will actually be perfectly read. So keeping this in mind, we're going to continue here and talk about different use cases, but always we will use the Sharp field of view calculator, this application here, using this new approach. We will do single lane simulation, and our furthest lane is going to be the left of the lane, while our closest lane is going to be the right edge of the lane. Now again, this is the top view here. And the general feedback we got from you guys is that this view is not very clear. Now this view here is what the camera sees. Now it might be good for us to give you this information, but some people are not sure how to understand it. Why is there 4 lines? Why is part of the line being in solid green while the other part is in dotted white? Well, this, as a reminder, refers to 2 pieces of information. First, we set up 2 lines. So we're going to have a simulation for the transit distance of plates on the first lane and the second lane. And then why is there 2 times 2 lines? Because we always simulate worst case scenario. We always look at the license plate in a very high position, the one we define as the highest expected license plate. And of course, we always look at those people with a sports car like Lamborghini, where the license plate is at a very low position. So again, here, if I attempt to illustrate this here would be our sports car, and the other line here would be our vehicle with a very high plate. And those 2 other lines would be the sports car on the other edge, and here it would be the utility or pickup, whatever you have in mind. Now, staying into this new configuration where those 2 lines refers to the edge, I'm going to attempt to give you a 3D perspective of this simulation. What you see here in blue, this cube, is your reading zone. Every license plate that will transit through this cube will be read. Now this, let me see here, perfect. This here is the right edge of the lane, while this is going to be the left edge of the lane. Of course, here we have 2 lanes because we always look at the lowest plate and the highest plate. So highest plate on the edge of the lane would pass through here, while the lowest expected license plate from the right edge of the lane would pass through this line. So any normal driver would actually be pretty much in the center of this shape. Here, if we take a license plate that would normally transit, it would do something like this. Using the field of view simulator to simulate a single lane with the settings give you a much better perspective and will help you exactly narrow down where is your reading block. This is pretty much what we could call our reading block, where every license plate that transits through it will be read. Again, I'm just going to give you this one more time here. Your license plate will go inside. Of course, I did not take the entire vehicle to make it more easy to read. Unfortunately, I can't hear you, and I don't know, guys, if this makes sense to you. I hope it does. Yeah, this is it. Now we have this in mind. Let's look about some mobile scenario. Now the field of view tool allows you to simulate both fixed and mobile scenario. And for mobile, it's a bit more challenging because you need to simulate and use as a reference point the position of your camera, which is likely to be on the roof of your car. Now this will be challenging because you have to recalculate the different number. Okay, let me illustrate this. When you use the field of view tool to simulate a mobile scenario, you can only do one camera at a time. And of course, you need to be able to gather lots of information about your environment, like for instance, distance to the edge of the road of your patroller, the parking space and size you expect, and information like this. Here again, here's an example here, a very simple example where we attempt to read a vehicle being parked at 90 degrees on the right side of the patroller and on the left side. Now, of course, when people parked, they don't always park the same way. So for us, it's very difficult to estimate where the license plate will be. Now you see here what we highlight here in blue. This is actually what we will use in the field of view simulator as the size of our lane. Because people may park at the very edge of their parking spot, or people may have a very small car and park all the way down to their spot. The license plate will not tightly be defined. So this is why we will take here a margin of error and simulate this as a small lane. Removing the background here, I'm just going to keep the vehicle and the different field of view setup. Again, in a document we're about to release, we will show you multiple case scenario, and for all of those use cases, we will provide you exactly the type of equipment you need, the lens you should pick, and the exact angle you should use based on what you intend to do. Here, for instance, we estimate that the license plate of vehicle being parked may range from 4.14 feet, this is annoying, here, at the closest, up to 11.75 feet. Now, any license plate, here this is, in this zone, will probably be red. Those are 90-degree parked vehicles. When you set up your field of view simulator, and I hope now this starts to make sense, the distance you should use to border the two edges of the lane should be the distance from the camera itself to the edge of your expected reading zone. So the distance from, let me go in red here, from this camera to this. Now this one would be the lane horizontal distance furthest. Here, let me highlight it for you. While the distance here from the camera to, I went a bit too far here, from the beginning of the reading zone would be the lane horizontal distance closest. Very interesting, isn't it? Your reading zone will be defined in between, here in this case, 10 feet and 6 feet. Okay. Enough with theory and concept. Now let's bring a few cases. So our product specialist actually did something like 10 different cases, which covers a wide variety of scenario. Very, very interesting and obviously a lot of work. Here in this webinar, I'd like to keep you alive. So I'm going to stick to 3 different cases. Of course, I don't expect you guys to take notes of the number. This document will be published. But I just want to give you a general understanding and an idea on how we will show you the information and how you should read it. So here we're back to the case I was covering earlier. And if you look inside it in the field of view, then as discussed, this is going to be the 2 edges. Now, of course, this picture has been resized, but the dot here you see is the actual camera, which should, to be exactly accurate, be placed here. Now, in this case, 90-degree parking, typical installation. The simulation would look like this. Now, I don't want to zoom in and look deeper into the number as they will be published. I wish, however, remind you something. Using the field of view simulator, you can actually save your work by simply clicking on File, Save, and your simulation will be saved in the form of an SFV file. Now, here in Genetec, we love those files. So if you do a simulation and want it to be validated or approved by Genetec, feel free to do it, save it, email us the file, and we'll be more than happy to have a look into it. We're also looking into providing you this information also in the form of SFV file, so you can simulate directly and maybe change a few things to see the different impact. Of course, here in this case, and allow me to go back a couple of slides. I want to show you this one actually. The reading distance here from the right side and the left side is very different because the driver here is driving on the right side of the road. The parked vehicle on the right will be very close, while the vehicle being parked on the left will be slightly further. On top of it, it would be a plus to be able to capture the license plate of incoming vehicle. For this reason, it is actually more interesting to select a different lens from the left, and of course a different configuration from the right. So if we look at the camera here that we picked for the right, which is a 8mm lens, from the left we're going to go for a 12mm, and you see the different angle being picked here are very different, and of course we go wide in this mobile scenario. Another case we've been working on here is what we call mixed mode. Now, mixed mode is really about capturing parked vehicle and capturing ongoing traffic, hence the name mixed. Now, if this is something that interests you or interests your customer, then we came up with different number. See, as you see here in in this setup, we will be able to read in a parking, driving on the right lane, and in a situation with ongoing traffic. Now, if you care for the detail, there is a slight difference between this illustration here, this one, and the one I've showed you a couple of slides ago. See here, if you remember, the vehicle was properly positioned on the right lane. Now here in this case, to get optimum result, you see that this person is actually slightly driving on the line. Now, of course, we will give you those information, and I said it and I will continue to say it, camera positioning matter, but the driving style matters a lot. And this is also why we produce those documents here. We produce those documents to show you not only how you should position your camera, but also how you should adapt your driving style for optimum result. Here in mixed mode, we are looking at the following configuration. So on the right, 12 millimeter, and on the left, we'll be using, let me see, 12 millimeter as well. Okay. Here we have the simulation for the right camera. And again, this is going to be where your vehicle will be. And in mixed mode, for the left, we'll be looking at slightly different angles. Now, I like to talk about another case here. We're going to call this one case number 3. Now, case number 3 is a very interesting setup. Here we're not going to do a usual 2-camera installation. We're going to go ahead and use 3 camera in this case. By the way, something we could easily do by using a Sharpx IP and having maybe 2 VGA camera on front position, right and left, and maybe using an XGA camera located on the trunk of the car to get other lanes. Now, I really like this setup because it's very versatile. It's going to allow you to, on road traffic, to capture your right and your left lane, but using the other XGA camera, because of the increase of pixel from your VGA camera, you will be able to capture the 3rd and 4th lane from the vehicle, allowing you to potentially cover a 4-lane highway. Again, this setup only requires 1 sharp processing unit. Now in this case it's slightly symmetrical, so the right and left front VGA camera will actually use quite a similar setup. Here is a 16mm lens, while your other lane, here the one highlighted in red, will use an XGA wide 25mm camera. And because we slightly like to spice up things here, if you look at the simulation we've made using the AutoVu tool, well, here, this line here is going to be the edge of the first lane you intend to read, while this line here, I'm highlighting in red, is going to be the edge, but not of the same lane, but of the next lane, which is going to be pretty much here. Now keep in mind, the AutoVu tool is a simulator and you're free to use it any way you want to get the information you require. So this is also a very interesting use case for the field of view simulator. Now, I'd like to give you guys even more information about this. In this case, we came up with additional information. Now, we know the speed could be a factor in how your system performs. Now, we wanted to be able to come up with numbers and let you guys communicate this information and know this information to have a better understanding of the product. The speed will have an influence on the range of operation of your system. Here, for 1 sec, I'm going to go back. We're not looking at the 2 VGA camera, not those 2. We're actually looking at this one here, the XGA camera. The one that's going to try to capture lane number 3 and lane number 4. Now, here, what we did is based on the speed of either your vehicle or the speed of ongoing traffic, we are showing you the difference it will have on your range of operation. Let's have a closer look here. So your camera is here, and as you see here, the slower vehicle or yourself drive, the highest your range of operation will be. Here, if you drive at less than 20 miles per hour, you will have a range of operation ranging from 15 feet to up to 32 feet, center being at 23.5 feet. Now, if you're driving at, let's say, something a little less than 80 miles per hour, then your range of operation will be reduced by about 5 to 6 feet on each side, giving you here what you see in dark blue. Sorry about that. Here, this would be our new range of operation, driving at 80 miles per hour. Here, for instance, if we go with a little less than 40 miles per hour, then we gain a wider field of view. So you probably knew this information already, especially if you did a few deployments, but we're very, very pleased to now put this information in numbers, and again, we will publish this information to our premium partner and other partners so they can have a better understanding and numbers. Again, here I decided to only cover 3 cases, which I handpicked. But our product specialist did a lot of cases, and again, we're actually working on making this document available. And again, while designing a solution, do not hesitate to involve us to validate your simulation. Moving on to another part here of planification. The collect of license plate for context update. That's going to be interesting here. As a friendly reminder, we use something called an LPR context. Now I like to refer those as LPR profile. And what this is really a regional optimization of the LPR engine to improve the ability to read license plate for a given region. Now this LPR context or LPR profile contains lots and lots of information. For instance, the type of grammar being used on the license plate. If there is a special code, like for instance, it must be 3 number and 3 letter, or maybe 1 number, 1 letter. The type of reflectivity of the license plate, possible known background, the font being used to help us do a better recognition. The dimension of the license plate, the layout, the structure, is it a one-line license plate, the spacing between characters, and much, much more. Now we gain all of this information and we put them in a context which will allow us to achieve very high reading accuracy. Now, of course, this is an ongoing process. If we do business in your region, we probably already have a context available and ready to go. Now, if this is a new market, we might not have a context, and we would be more than happy to start creating this context for you. I just wanted here to show you a few license plates from from different countries in the world. So let's step away from the usual North American and European plates, and let's look at what they have in India. This here is a plate from Saudi Arabia, which we actually have a context for, and we read those plates very well. Those are 2-line plates with Arabic character. And here I wanted to add Turkey, which is very European when it comes to the license plates from Singapore, and of course I couldn't put no plate from the US. Now, let's talk again about this process here. Not only we might have to create a new context for a new region where we don't have an existing context, but sometimes something people in the US know very well, sometimes the background change or the entire license plate structure change because the state needs money. And they're like, hey, let's do a new fancy plate. Sorry. And of course this could be fine for us because the changes are minimum, and sometimes the changes could be quite drastic. Maybe they could change the reflective property, and we will need to do a context update. Now, context update will be integrating the new grammar rule, integrating new potential background, or integrating a new font being used with the new license plate. Here, for example, I was able to get a license plate from, I think it's Uzbekistan. Here's a picture. Now, we don't have a context, as of now for this country. But this is coming. Now this plate actually works quite okay using European context. Because those are very big characters, they're pretty easy to recognize, but we're not quite there yet because of the specificity of the license plate. Here, for instance, something pretty unusual, the two first characters are a lot smaller than the rest of the plate, which is unexpected. And of course, we need to teach our equipment how to know what's the difference between a 0 and an O, for example. Here, for instance, we probably need to know in the first place if this is a 0 or an O before we make any decision, looking at those two characters. Now, of course, this is one plate amongst many more, and if we develop a context, we need more than this. Now, you'll see where I'm going with this. So, we have a special team here in Genetec, and they are specialized in creating context, and they might need your help. Now, some people here probably know exactly what I'm talking about. When creating a context, we might need a local presence on site to collect plates. And maybe there's lots of misunderstanding or miscommunication about this, so I'm going to take this opportunity here, this webinar, to talk further about this and maybe cover how exactly we do it. So if ever Genetec asks you to collect license plate, we don't expect you to go to the nearest shopping mall and steal license plate, okay? We can do better than this. If we ask you for a collect of license plate, this is actually something that you can now do from the Sharp portal. Previously, you had to use a special tool called the integrator tool. Now it's directly embedded from the web page, and anybody with the Sharp tool or Sharpx will be able to do an image capture. Here, if you log onto your Sharp portal and head over to the live feed section, which is the third tab, there is a subsection here called image capture. And when you're ready to start your capture, this would be your starting point. This is what we will call a recording session. Now, once you hit the recording button, here it's going to prompt you with this page here, image capture. It wants you to define a local folder, not on the Sharp camera, but on your laptop, where you want to store the information, and it's going to prompt you with pretty much two options. How do you want to do your plate collect, and for how long? Now, the more license plate we have, the more happy we are. So here, 15 minutes would be a bare minimum. Now, when it comes to the following option here, either you go to save all images or you pick save images associated to a best read. Now, what decision you should make here depend on what you do. If this is a brand new context for a license plate, we don't have an existing, for a region we don't have an existing context for, we would ask you to go for save all images. If we are talking about doing an update on an existing context, then here in this case we already have the foundation and the general knowledge on how the license plate pretty much is, so we can go with the other option, save images associated with best read. Now, the reason why this option would not do any good for a new context is we can't know if this is a best read because we don't know what to expect in the first place. So again, general guideline here is if it's a new context, you save all images for a period of time, and if it's a context update, you probably go for only the one images associated to a best read. Here what I did is I picked save all images, I picked 15 minutes, I clicked on start with a local folder on my laptop, and I let the system go for 15 minutes. You pretty much have nothing to do. The camera will do all the job except of course driving and finding as many plates as you can. And here if you check the web page, you will see this number incrementing. Once the recording session is over, we will build a zip file here on the location you picked. And this zip file will contain all of the information we need. Here is some generic best practices. We love shopping mall. They have lots of license plates, and they have lots of license plates from different parts of the region and maybe from multiple states, which gives us even more information. When doing a new context, we like to have recording session done during different period of the day. During daytime, at nighttime, at dawn. If you can even get a rainy or a cloudy day, it's even better. The more information we get, the easier it's going to be for us to work. Now, I said you can do that on pretty much any Sharp camera. It's not entirely true. You need to make sure the illumination works with the type of license plate you're reading. So if you have non-reflective plate, you will need to use our specific illumination for those types of plate, 590. If you have semi-reflective plate, or if you have completely reflective plate, the appropriate illumination will be very, very important. So again here, just let us know, and we will be more than happy to advise you on what type of illumination, and if you are in the process of doing a plate collect, I'm sure we could find a camera for you with the appropriate illumination. Eventually, at the end of my 15-minute license plate collect, I ended up with a file of nearly 1.4 gig. So yes, it's going to collect a lot of plate. So expect it to be quite big. And I was able to get about 2,219 images. And I was actually looking at the same plate all along. We will collect images, we will collect metadata. So for you here at this stage, the only thing you have to do is take the zip file and send it to us. We might even provide you an FTP access. So before we talk here about the deployment questionnaire, I'm very happy about this. Now the plate collect is a very straightforward process, and you can do it on any camera using Sharp Portal. So even if you don't do a plate collect and you want to be more familiar with this process, give it a shot. Try it for a few minutes. It's very straightforward, and when the time comes, you'll be able to assist us. Moving on here to section number 5, AutoVu deployment questionnaire. Here, I don't want to spend too much time on this. We're all about helping you, and we're all about making the process of a deployment of an AutoVu mobile installation smoother for Genetec and for you, the integrator. So, and we know such mobile deployment could be quite complex, and gathering all the required information could be a difficult process, and yet is critical to the success of the deployment. Now, what could happen here if you fail to collect all of this information, and then you go on site and you start deploying, and there's something wrong with the server, and you miss the information to talk to the IT, they are not available. You know exactly what I'm talking about if you've done at least one deployment. Now, the questionnaire will help you better define the scope of your project, identify on-site resources that will be able to help you and support you during the process of deployment. Of course, it's going to ease the logistics involved in the deployment and avoid communication problem becoming a showstopper. Like you can't work anymore because you're missing one key resource. This questionnaire should be filled by the end user, or at least with the help of the end user, as it's mostly a question about him. I've got this document, and of course it's going to be soon available. But here I want to talk about it here just for a minute. We have different type of questionnaire depending on the type of package you intend to deploy. Here I decided to pick a mobile university system as an example. And as you see here on the left part, we have information about the different contacts on site. Quite important. We cover here all the basic functionalities like the type of zone, how many parking lots will be used, is there maps of the campus available, are the parking roles already provided, any hotlist, the hotlist structure, so you know what to expect, you know if they will comply with Genetec, and much more information like the retention time, so you can already plan for the storage and the need for a database or not. here are on the left here, at least enforcement information. This is for university permit, here this part. And of course, when it comes to the server information, server and network scheme, all of the information you need to go on site and start deploying without running after many people. So this is critical to a successful deployment, and this document will have to be filled by the end user prior to any deployment. All right, so let's go to the second section here for this webinar, deployment. And talking about documentation, I'd like to talk about a new piece of documentation, another one, which is called the AutoVu field report. Now, this document here will have to be filled once the deployment is complete. And the intent really is to gather a lot of information about the deployment to make sure it was done properly and to make sure the installation is easy to support. So at Genetec, we would like to ensure consistency across AutoVu, across all of our AutoVu installation. We would like to have accurate documentation for any support or later maintenance. And of course, having a successful implementation of the AutoVu product, pretty much we'd like to have all of our customers very happy. And I'm sure this is something you do too. Now, the field report or installation report, if you will, would have to be filled for any installation. Again, I'm not going to look into every detail of this field report. It's actually quite lengthy. So here, I just took the table of content and I looked at a few sections. For instance, here, some contact information, just like before. Some installation detail, where the wire run, what is the equipment installed. As usual, we'd like to know the network scheme, IP address being used, type of equipment. Eventually here, if you look at, I know it's a bit small, section 4 here, system configuration, we'd like to have the alignment value. We'd like to know exactly what angle has been used and of course the type of equipment. If there is any custom solution, which of course add additional challenge for support, we would like to know about it. So for us, looking at the field report will allow us to better support or assist you into doing better support if the time comes. So again, in the field report we will include network scheme, hardware list, wiring specifics. We love picture from inside and outside the vehicle, and here's something very interesting, system performance. Yes, we would like to know how well the system is doing once you give it to the customer. Now we're going to talk a little later here about system performance, as it's a key aspect of a successful deployment. But before, I'd like to talk about navigation and navbox. The general feedback we have from you guys, installer, is that there's a few tricks to know about the navbox to do successful deployment. So when it comes to navigation, we have a couple of options. To give navigation options to a system, you may use a simple USB GPS like the BU353, the one we have on our price list, which will give you regular GPS positioning, which is a very good solution for many deployments. In the case of a deployment where you do wheel imaging, you need additional accuracy. A USB GPS will not give us accurate enough information for wheel imaging to be functional. In this case, you will need to use a navigation box, what we also call a navbox. Now, the navbox is a multi-purpose positioning device. It embeds its own GPS. It also embeds a gyroscope, kind of what you have on your iPhone. And it also embeds a sensor for the speed of the vehicle, a speedometer sensor. Now, GPS positioning is needed to give us position on patroller. The speedometer and the gyroscope will be required, and maybe here I should have put it in bold, here required, for any setup that include wheel imaging. This is completely mandatory for any city parking with wheel imaging. Now, troubleshooting navigation, talking to our specialists here in Genetec and our support team, of course, they came up with a few statements they can hear on the phone or by email, and here they are. The GPS is connected, but the vehicle indicator is not showing up on your patroller map. Now, what could be the problem here? One thing you could do to troubleshoot this is on the patroller, if you right-click on the icon, you can get the IO services box. Now, this is going to show you interesting information about your GPS, and it will tell you how many satellites your GPS is currently picking up. Now, for the sake of accuracy, if we get less than 4 satellites, we will not provide you GPS coordinates because we assume they are not accurate enough. So reviewing the number of satellites is a good first step when troubleshooting navigation. Now, you do have your vehicle indicator on the map, but it's maybe a bit off or it's completely inaccurate. Again, if this is the case, you would start by checking the number of satellites and look at the quality of the signal. Same place, IO services, which you can get by right-clicking on the patroller and selecting IO services. The vehicle is sometimes going further away on the map when stopping at an intersection or stop before the intersection. And in this case, you're using a navbox. Here we have different possibilities. If you use a navbox with odometry, it is very important to check the scale. Now, the scale is what the navbox will use to know or to estimate the actual speed of the vehicle. If the scale is off or improperly configured, then your speed information we collect from the navbox will be wrong. If this is the case, then we will assume that the vehicle drives either faster or slower than it actually drives, misplacing the vehicle on the map. If this is your case, we actually have, you might have to do a calibration. We also have a navbox oscilloscope, which will show you the ticks. In other words, the signal speed of the vehicle, so you will be able to see if you have a noisy signal or if this is accurate. Also, it's very interesting to check how accurate your speed is at a low speed. Under 5 miles per hour or maybe 10 kilometers per hour, the system could be noisy and the noise could actually be seen as ticks and leading the navbox to believe you're actually driving much faster than you are. So this is also something you should check. If you have noise problem, then probably get in touch with the support team, but one thing would be to have a noise cancellation device. Other troubleshooting tips here for navigation. The vehicle is sometimes starting to snap out of the road and start to go anywhere in circle, usually very large circle, even if the driver is actually driving straight. So, see, in this case, this is likely to be related to the gyroscope of the navbox. So, one typical case is your navbox is improperly set up. For the gyroscope to be fully functional, the navbox must be installed in a very flat horizontal position and cannot move while the vehicle is moving. So it must be properly installed and bolted to the vehicle to make sure it's always in the same position. This behavior may happen when driving during a long period of time, for instance on the highway. In this case, we would advise you to review the stop value. So there's 2 settings with the navbox, the scale and the stop value. Now look at your stop value and try to lower it. It should be around 1 or something very close to this number. So if you have a very big number, maybe you should be concerned. In a case where a navbox has been deployed before 2014, then you might want to validate the firmware the navbox is running. We've done a fix and you need to check if you run the latest firmware, which is 4.17. If you want to get more information about this, feel free to get in touch with our support team. Moving on from navigation options, I'd like to talk about wiring guidelines. Now here, unfortunately, there is a lot to talk about, and we could dedicate this entire webinar discussing the different aspects to wiring. Now we feel that we need to talk about it here in this webinar because it's actually, according to our support team, the root of many problems in a mobile installation. I would preface this section by saying that we're coming up with documentation. A guide called the AutoVu Hardware Installation Guide for Sharpx Mobile is a pretty extensive guide, very well written, and covers a lot of consideration about wiring guidelines and actually much more. Improper wiring in an installation may result in the following: general dysfunction of your AutoVu system, so it's just not working. It might lead to require short-term maintenance because after a while it stopped working. Some very random, unexpected behavior, and some occasional malfunction. I'm going to continue by talking about this guide here, again, the AutoVu Hardware Installation Guide for Sharpx Mobile, but I can only touch on a few things while this guide is extensively covering those points. In this guide, we will talk about some safety notices and warning about AutoVu mobile installation, Sharp camera and Sharpx camera. We will also discuss how to power up and connect your Sharpx or your Sharp 2, how to install tire camera on a vehicle for wheel imaging, the camera alignment process using our alignment kit, and how to set up the navigator box and how to calibrate it. Some additional information will be available. One thing I've noted, for instance, is the LED status and their meaning. So you know there's an LED on a Sharp 2 or a Sharpx, and the type of blink will give you interesting information about how the system is behaving. It'd probably be a very good thing to know exactly what the LED blink means. Here in this illustration, I actually picked one part of the guide to show it to you real quick. On top of the guide here, I handpicked a few guidelines here, which I'd like to review with you briefly. Most of it might sound obvious to you, and yet our experience on the field proved that it's worth mentioning. So first, validate that there is sufficient space in the vehicle to mount the laptop, the processing unit, and the wheel imaging and LPR camera, obviously. Verify that there is a vehicle speed sensor that meets Genetec requirement. Now this is very important, and this could be also why we would like to know what type of vehicle you're installing, because it's a different story for every vehicle. Because the wiring schematics of any vehicle is different. Finding a working speed sensor might be very difficult. Sometimes a third-party speed sensor might be required, and again, if we know the vehicle, we will be able to know this before the actual deployment. The third point, inspect the vehicle before beginning the installation. Check the vehicle functionality, make sure everything works. If you start cutting wires and realize that one of the tail lights doesn't work anymore, make sure it is your fault and it was working before. This could have consequences. Inspect all of the AutoVu components we deliver to you on site. Ensure that there are no missing or defective components. Of course, this is like a pre-installation, very important step. During the installation, routing power wires from the batteries through the vehicle firewall and away from abrasion is mandatory. preferably routed through existing wire channel under the door sills, where they remain protected. Connect the 14 gauge power wire from the LPR processing unit plus terminals through the 15 ampere inline fuse. The primary power lead from the battery is fused within 2 inches of the battery. Do not splice any wire power or signal wires. If the wire you are installing is too short, replace with a new longer wire. Splice are a point of possible failure, causing the system to malfunction and many other side problems. Label all of your wire connection. This will help you identify your connection. This will help the next service technician to identify your connection when servicing the vehicle. Eventually make sure that all electrical connections are insulated. This protects against accidental electrical short circuit both during and after the wiring installation process. Again, those sounds like very basic engineering guidelines, but follow them. And again, I would invite you to review this guide. We're going to release shortly. Let's talk about the Sharp processing unit installation. We are coming up with new tools for the Sharpx setup, which I would like to show you. First, this is a document here called How to Power Up and Connect Your Sharpx, which is currently available on the GTAP. Maybe this is a newer version, but as soon as it's completed, we will put it there. So remember to jump to the GTAP to get this piece of documentation. One thing we're coming up with is a new RG45 connector, which is now going to be passed through. It is going to make your life a lot easier when making the Sharpx cable. By being passed through, you will be able to properly position all 8 wires. By the way, we followed this certification here, and this is going to be easier. Once you pass through the cable, twist the Cat5 wires together, and then using the Easy RG45 connector into the corresponding slot on your Easy RG45 crimp tool, and then firmly squeeze the handles together. The crimp tool should trim the wires end, but you can trim them further to make sure they are flush with the connector surface. So we even have a couple of screen capture here, and this is all in the how to connect and power up your Sharpx. So have a look at this document. Eventually you might have heard about it or not, but it's about time we release a cable tester, a Genetec made cable tester, which will let you make sure your Sharpx and Sharp2 cable are fully functional. Now this is something you will need to get your hands on, as it's going to be a very important product for our deployment. Now excuse the quality of those pictures, but it's a pre-release, but this is how it looks like. Now this cable tester will let you connect one end of your Sharpx to the cable tester itself, the camera end, and the other end will be connected to a termination which look like this here. I'm just going to highlight it. Here we have the network connector and the other connector. Now as you connect the Sharp cable you just made, you have to put it into Sharpx mode. Should you test the Sharpx cable, here you click on push to test, and it's going to show you if it's okay or if one of the wire is not functional. So that's going to be very, very handy on site. Now with the same cable tester, we're going to give it to you with both the Sharpx termination and the Sharp2 other termination. Here is the connector for the Sharp2, and you will be able to test it as well. Of course, make sure you toggle the switch to Sharp if this is a Sharp your test. This is a standalone cable tester. It requires battery but does not need to be plugged in or anything to work. So very small, very easy to carry. So no excuse to not test your cable before installing it. Eventually, when I started this webinar, I talked about a quiz at the end of this webinar. Now, if you take this quiz and you do good, well, we will be more than happy to ship to you to the top 3 scores. One of this cable tester once it's ready. It's not released yet, but it's coming very soon. So now you have no excuse not to take the test. Speaking of a new tool, we're coming up with a new benchmarking tool. It's a piece of software which we call the performance analyzer. Now, coming from the support department and talking to my fellow colleague, field engineer, that goes on site, doing a performance analysis is often a very time-consuming and tedious process. And we've been looking into it, and we wanted to come up with a software that would do most of the job for you. And I say most of the job because you still will have to do a teeny part. Now, the performance analyzer is a tool that allows you to quickly evaluate the performance of your system and will allow you to save the result in a standardized format. There are 2 ways to get data into the performance analyzer. From Security Desk, you generate any read report you want and you do an Excel export. You need to include the picture, it's very, very important. Another way is to do an image capture from the Sharp portal, and you will be able to use the zip file generated and put it inside the performance analyzer. To be able to benchmark a system, you require pretty much 3 things. Microsoft Excel. You will require the software itself, the performance analyzer, and at least a read report in XLS or the image capture. To start using the tool, execute the file and take your XLS report and drag and drop it inside the tool. The file will be loaded and it's going to look like this. Now, here we only see 1 license plate, but as you see here, it loaded the entire file and all of the other license plates are under this one. When you load the tool for the first time, your capture rate and your read rate will be at 100%. Here we have different information. We will show you the plate image. We will show you here the plate read, which is what the system read. Here it's always going to say correct, which does not mean it's correct. Stay with me. And here you get the confidence score, if the confidence score is available. Now, where you need to start is here, on the ground truth. Now, this is the actual plate. Now, by default, when we load a file, we will pre-fill this for you, making the assumption that the system did perfectly. So, in other words, we will take the plate read and we will copy it into the ground truth. Now, here the key of the exercise is to review all the plate using the plate image, and if one is wrong, you will have to retype here the license plate as it really is. So this one seems okay. So at the beginning, the ground truth is a copy of the plate read, and the field is editable, which is something you will have to do. In this step, you will need to review all of the license plates and start editing it. It's not that time consuming, because if the plate was properly read, there will be nothing to edit. Alright, let me show you an example here. So here, for instance, we look at this plate, which is SJT917G, and the system misread this plate and read JT917G. Obviously, we're missing the first character here. So what you have to do is go here and type the missing S. As you type the missing S, the performance analyzer will update, and instead of showing you a correct, it will update the information and showing you a bad, because this character has been omitted. Now it's color coded. You will see here in dark green correct when it's a correct match. If the plate cannot be matched, it's going to show you bad. And if this is not a license plate, maybe it's a traffic sign, maybe it's some advertisement on a vehicle, then what you will have to do is empty this field, and then it's going to show you a false positive. Now it's very important you do that, so when you get your statistic, we will make a clear distinction between a misread and a false positive. Eventually, I haven't talked yet about fuzzy matchable. Using your currently fuzzy logic rule, let's say for instance you allow one OCR to be permitted, then if the mistake is only about one OCR, instead of showing you bad, we will show you fuzzy matchable. Now, see here for instance the license plate read JZ93978. Now let's say we read the it's a B. Let's say we read the B for an 8. Here it would show fuzzy matchable because B and 8 are OCR, and we might tolerate up to one OCR depending on the rule you use. One OCR would be the default. Eventually, I'm going to stay on the slide. Eventually, once you review your entire reads, your 100 or 200 reads you've exported by editing all the one where there was an existing mistake, the performance analyzer will populate the result into different way. And it's up to you to decide how you want to get it. The first way, the one by default, is in percentage. So here, for instance, out of 100%, 95.3% were properly read, 96.5% would be properly matched based on your OCR rule. We have 3.5% of bad plates and 1.2% of false positive, in other words, where I emptied the field. Another way to format the data is in number. So here in this case, my report was 85 and 81 were properly read, 3 bad plates and 1 false positive and 1 matchable. If your exported report contains a confidence score, which is now available since Sharp OS 10.1, then we will be able to use this confidence score to give you a much more accurate analysis. Excuse me. Here, for instance, using the confidence score, the system will be able to tell you exactly when, on what confidence score we did the most mistake. Here we see that many plates having a confidence score around 40 were actually misread. Now this is something I did here for this presentation on my own, but of course if you try the performance analyzer, you might expect to see a lot of problem on the low confidence score, and of course the high confidence score should be just fine. Now this is very interesting, and I want to add here on a side note, the performance analyzer has been designed so you can evaluate Genetec system, but technically, since our input is an XLS file, you could analyze another system as well and see how we compare. The performance analyzer will be ready soon. We haven't yet decided where it's going to be populated, but it's going to be available to all of our AutoVu partners shortly. This is it for deployment. Here I want to take the rest of this webinar. Don't worry, that won't be too long, and talk about some interesting support tools and feedback we got from our support team. So let's talk about new and old troubleshooting tools for Sharp and Patroller. You might have noticed, but since the last version of the Sharp portal, it's now possible to export and import settings from a Sharp portal. One easy way to back up your information, so if someone would change the configuration, you can still restore it. Something that is also very interesting for our support team, which would be more than happy to get this information should they need to troubleshoot a Sharp camera. The Sharp image or AP image can now be checked from the portal itself. It will be displayed directly from this page here, and it's going to show up here on the edge. So you will be able to know what is your IP image without having to do a Windows remote desktop session. Eventually, you might not have noticed yet, but there is this small bubble with an interrogation mark. This is contextual help. Now we talk a lot about contextual help in Patroller, which will show you the help you need based on the page you're on. I'm very, very happy to tell you guys that now contextual help also applies to the Sharp portal. So depending on which page you are on the Sharp portal, clicking on this box will actually show you relevant information about the page you're looking at. Here, for instance, I'm on the configuration page, and if I click here, I got lots of information about this configuration page and all the links I need. So again, very useful, and this is to be used and abused. On the Patroller config tool, we usually call the PCT, there is under the General tab a test connection option here, which will test the connection not to Security Center, but to your local database. It's going to make a quick test to make sure we have enough privileges to be able to read and write information onto it. So a necessary first step you should do when deploying a new Patroller is do a quick connection test to make sure that you can access your database. If you get this message here, connected, you're good to go. Some other useful options here, since we talk about the Patroller config tool. There is the ability to show the default value. So if you know someone has been changing the configuration, or yourself, and you don't remember what you changed, feel free to click here on show default value, or just do Ctrl D, and it's going to show you what was the default configuration. This will apply on any configuration page. You have a reset option that will reset the Patroller settings. So you, just like the Sharp, you can import and export the settings of a Patroller to another one, or for us to troubleshoot, by just clicking on those two import and export options. Very simple to use and very convenient if you have multiple Patroller to set up. Talking about the configuration navbox, one problem our support team noticed for quite some time now is if you use a docking station and you have a navbox connected and somehow you change the USB port or you undocked your laptop, the COM port being used by the navbox might change. This is something Windows does. And if the COM port change, or if you don't know what is the current COM port, then now we have the option to detect it. We will automatically detect it and tell you where your navbox is. You'll be able to properly do it. Now, this applies to the odometry. It also applies to any USB GPS, where you will be able to do the same. Now, I'm going to let you into a small secret. Maybe you know that already, but in the next version of Patroller, this will actually be auto-detected every time. So even if your COM port change, we will automatically adjust and put the new one. So this is going to be part of the past, and you won't have to worry about being on the wrong COM port. So that's very exciting news here. Eventually here I want to talk about real quick here a few troubleshooting tips from the support team again. So a few things here I was able to collect, which could be relevant to you. On a Sharp camera, you can actually type the password directly in the URL. This could actually let you save a few sec. You just have to type it this way, so usual IP address or Sharp name /portal / and here you put interrogation mark pw equal Genetec or any other password. We have a advanced mode available on the portal, which you can actually access. When you're on the logon page, instead of clicking on OK, hold the Control key and click on OK. It's going to show you the advanced page for the portal. Now, there's not a lot of difference, but one thing you will notice here, if you are in advanced mode, is you will have this additional box here, services, which will let you stop the plate reader services or just see if the plate reader services is currently running. Again, this is a good trick, so you don't have to do a Windows RDP if you need to know about the plate reader. So again, hold Control when you click on OK. Quick feedback here on a mobile installation with city parking using permits. Now, something we noticed is when you use permits and when you start the application and you start enforcing a permit zone right away, you might get the first few reads, they might show up as permit it, regardless if those are actual permit it or not. This is there's actually a simple explanation beyond this. It's because when you start the application, your permit files are still processing. Now this is usually quite a fast process. It could take from a few seconds to minutes, depending on the size of your permit list. But it's always good to keep this in mind. So when you start enforcing, allow the system some time before it's completely ready to work. The last hint and tricks is about shared permits. For some reason, shared permits in university mode is an often misunderstood feature. Now, I would preface this by saying that those people did not attend an AMC class, or else they would know. Jokes aside. Now, what is shared permit exactly? So if we look here at the AutoVu handbook, shared permit is described this way. Now, I'm not going to read this. What it says, to make it simple, is a permit, a license plate, is attached to a permit ID. Now, if you're a student and you have multiple cars, you might have actually multiple license plates attached to the same permit ID, should your university allow this practice. Now, if you have multiple license plates attached to the same permit ID, a simple rule would apply. You can only use one vehicle at a time to go to the university and have the right to park. If you, for some reason, decide to land one of your vehicle on the same permit ID as your other vehicle to go on campus at the same time, this is going to be seen as a shared permit violation because two vehicles use the same permit ID, and it's a way to scam the university permit system. Now, how do you trigger a permit it? Well, this is the catch. The same patroller must read two license plates that belongs to the same permit ID within a given period of time. Now here I say X minutes. Now this X minutes can actually be defined under the config tool, under LPR Manager General Settings, which is here. And here you have settings here at the bottom, which says maximum elapsed time for shared permit violation. And by default, it's set to 2 hours. So I'm going to try to rephrase this here one more time. What it means is, if I have two vehicles, ABC123 and DEF456, and if the same patroller picks up those two license plates, which belongs to the same permit ID, within 120 minutes, then the system will automatically raise a shared permit violation. Now, there might be cases where this 2 hour time limit might not make sense. For instance, if I am a student, I go on site at the university using my first vehicle, I leave the campus to have lunch, I come back at the beginning of the afternoon using my other vehicle, yes, it might raise a shared permit violation if I am within those 120 minutes. In this case, it can simply be discarded, or if this is a problem you see often, you can lower this number to 60 minutes. Now, what our system will not do is, if one patroller picks up one of the plates from a given permit ID and another patroller picks up another plate from the same permit ID, we will not raise a shared permit violation. Now, that's a legitimate case, but the reason why we will not raise this shared permit it's because patrollers currently are not able to communicate between themselves, which means patroller 1 is not able to tell patroller 2 that it has seen this plate and this license plate. And this is why here I'm highlighting it has to be the same patroller who see both license plate from the same permit ID to raise the shared permit. So now I hope this explanation will make the sense of shared permit much better to all of you guys. And of course, you're free to change this number to a bigger number or a lower number, depending on the university current regulation. Eventually, shared permit was our last topic today. So this is it, folks, for this training. I was very happy and very proud to give this webinar today, and lots of exciting things to come. Now, maybe you're very eager to get your hand on, to be the first to get your hands on those cable tester, and this is where we will give you a chance. So I want to give you some more information here about the quiz, which you may start taking now, you may start taking it later today, but we will only keep it open for the next 4 or 5 hours, and then it's going to be closed. So don't miss this opportunity.